All right, in this video, we are going to be graphing rational functions. Pretty exciting stuff because this is actually the culmination of the last several videos that we've been doing and pieces together a lot of the different things that we have explored with rational functions. So, first things first, let's get an equation. Let's go with f of x equals 3 over, oops, let me try that again. It's writing and clicking no at the same time, x minus 4 squared. Okay, so first things first, like we generally been doing, we want to first see if we can factor this. And I'm not seeing anything in here that indicates it's factorable. So we're good on that front. The next thing we want to do is look at 5 different pieces of information. And from these 5, we're going to get a rough sketch. Keep in mind we're sketching this. We're not going to get a perfect looking rational function. We just want an idea of what it's supposed to look like. So the first thing I want to do is I want to figure out what my excluded values are. And then from there, I can go a little bit further. So again, excluded values are when the denominator equals 0. So I'm seeing right here that we have an x plus 4. It doesn't matter that it's squared when I'm finding excluded values. So that tells me that x equals 4 is going to be an excluded value, or x cannot equal 4. And graphically, what that means, because that factor will not cancel with the numerator, that's going to give us a vertical asymptote. So the first thing I want to look for is a vertical asymptote. And that's at x equals 4. Then I'm going to look for any holes in the graph. Holes in the graph would be factors that did cancel with a numerator. And because I'm not seeing anything there, I'm going to say that there are no holes. Then I'm looking for horizontal asymptotes. So for a horizontal asymptote, that's why we were doing limits as x approaches infinity in the last video, because that's the definition of what a horizontal asymptote is. As the function goes to infinity, what is it leveling off, or what is it approaching, if anything? So I'm going to take my function, limit as x approaches infinity, of 3 over x minus 4 squared. Now again, I'm looking for the highest degree in the numerator and denominator. I'm seeing that it's in the denominator because the degree in the numerator is just 0, so not worrying about that. If that's the case, a number over infinity will give me 0. So my horizontal asymptote then is f of x equals 0. Then, this is the tricky part. I want to find intercepts. So if I want to find the vertical intercept, actually, let me find the vertical first because I think it's the easier one. To find the vertical intercept, I want to know where it crosses this vertical axis. And if we have the vertical axis, that means my input has to be 0. So I'm going to take x and plug in 0. So I'm going to find f of 0, which is 3 over negative 4 squared. So it's 3/16. Not a nice number, but it's something we can certainly work with. And then the last part of this, I want to find the horizontal intercept. And for the horizontal intercept, I'm going to go backwards. Now I want to find where it crosses this axis, which means the output is 0. So I'm going to take my function, 3 over x minus 4 squared, and set it equal to 0 and solve. Now, to do this, I'm going to actually set up an equation like that, and that can help me cross multiply. So 1 times 3 gives me 3, and 0 times this quantity gives me 0. So lo and behold, there is no horizontal intercept. Now that I have these 5 pieces of information, I'm going to start graphing this. So I'll start with my vertical asymptote at 4. I'm just going to draw a dotted line there. There weren't any holes. I have a horizontal asymptote at 0. My vertical intercept is at 3 over 16. So 3/16 is just slightly less than 1/4. So right around there or so. And it does not have a horizontal intercept. So it doesn't seem like I have much information here, but I actually have everything I need to graph except for one little piece. When I've got a rational function with one vertical asymptote, it's going to break up this graph into four separate regions. We have the upper left, upper right, and lower right. Because that vertical asymptote is a boundary, if I'm looking to the left, it's either going to occur in the upper half or the lower half. It can't occur in both. So because I'm seeing this point here, it looks like it's probably going to go in this area and kind of level up. The way I like to describe it is going to hug the asymptote. I'm going to try this better because that's not a very good graph. Let's try that again. So it's going to hug the asymptote, round up like the corner of a desk, and then hug the other one. So that's what my rational function roughly looks like. Again, it's probably not 100% accurate. That's okay. We just want to sketch. Now to figure out the other part on the right-hand side, I'm going to take any value that's to the right of 4, so maybe a 5 or a 6 or whatever, and I'm going to plug it into this function. So I'm going to take, let's go with 5, since it's right there. And when I plug 5 in, I'm going to get 3 over 5 minus 4, that's 1, squared. That gives me 3. So the point 5 comma 3 is going to be part of that graph. So in this case, the graph will go in this upper right quadrant and do something like that. Now, if we start getting more advanced in these, we can look at the equation to begin with, we could see that the denominator was squared, which would indicate that the left and the right values are going to approach the same thing. And that numerator will tell us what it is. If there was a negative on that numerator, then both pieces would go down. But because it's positive, they're both going up. Okay, let's do another example, similar, but maybe a little bit different. In this case, we're going to do g of x equals 2x squared minus 5x minus 3 over x squared minus 8x plus 15. Just like we've been doing with the other ones, the first thing we want to do is attempt to factor. So I'm going to start with the denominator, because that's an easier one to factor. And I know that's going to turn into x minus 5 and x minus 3. Now, the reason I'm picking the denominator, not only is it easier, but it's going to help me strategize on what the numerator could factor to. Based on the two factors here, it's likely that one of my factors in the denominator will also show up in the numerator. And lo and behold, I'm thinking that the x minus 3 is the factor that's going to show up. So now it's a matter of piecing together the other part, which would definitely be a 2x to give us 2x squared. And I believe a plus 1, let's just double check. That's negative 6 plus 1, that's negative 5. We're good. All right, we have two excluded values. X cannot equal negative 5 or positive 5. And x cannot equal 3. But those excluded values are different types. The 3 indicates a hole, and the 5 indicates a vertical asymptote. So I've got part of two pieces already. So my vertical area and my vertical asymptote is at x equals 5. And let's just finish this one off here, so I forgot to finish reducing it. Because we're going to need it now. When we have our hole, we have one at x equals 3, and we want to find the y coordinate. And to do that, I'm going to take 3 and plug it into here. That gives me 7 over negative 2, so negative 7 halves. All right, horizontal asymptote. We take the limit as x approaches infinity of our reduced function. It actually doesn't matter in this case if we use our reduced function or our original function. We're going to end up getting the same thing. So I'm looking for the highest degree in the numerator and denominator, just happens to be x. So this is going to act like 2x over x, which will then reduce down to 2. So my horizontal asymptote is g of x equals 2. A vertical asymptote or vertical intercept, I want to know what happens when I plug in 0. So g of 0 into the new function, not the original function, is going to give me 2 times 0 plus 1, so that's 1. And 0 minus 5 gives me negative 5. So my vertical intercept is negative 1/5. All right, and then the horizontal asymptote or intercept. This is where we're going to take the equation and set it equal to 0. So I've got 0 equals 2x plus 1 over x minus 5. I can again set that up as a proportion so that I can cross multiply. So that gives me 2x plus 1, and the other diagonal gives me 0. So when I solve that, I'll take away 1, divide by 2, and I'll get negative 1/2. So that's my horizontal intercept. All right, so now I put these pieces on the graph. So let's start with our vertical asymptote we said was at 5. Vertical asymptote there. My horizontal asymptote was at 2. And I have a hole at 3 and negative 7/2. There we go. Pretty close. A vertical intercept of negative 1/5. Oops. Let's try that again. Negative 1/5. And a horizontal intercept of negative 1/2. So we got a rough idea of where it's at. Now at that point, I've got 3 points that fall in this region. It's pretty safe to say that that region right there is going to be covered by a rational function. So I'm going to take my graph, round it off, and hug that asymptote. So that's the first piece of the graph. The other piece of the graph is going to be something to the right of 5. So I'm going to take 6 and plug it into this reduced fraction. Again, I'm picking 6 just because it's so close to 5. So 2 times 6 is 12, add 1, it gives me 13. Might not be a good choice here. And then I plug in 1, or 6 minus 5 is 1. So let me try a different point actually, because that's 13's off our grid. That isn't going to help us. So here I'm going to take 7 times 2 is 14. Add 1 gives me 15. And 7 minus 5 gives me 2. So that's probably better. 7.5 effectively. So I'm going to go to the point at 7. And at 7.5. And so I know my graph is going to have to go through, and oh, that's not a very good rational function. Come on, let's try that again. So I know at 6 it was up here. It's going to start leveling off, and I got a little better, but not perfect. But that's going to give you a general idea of that rational function and what it should look like. So again, our first step is still the factor like we've been doing. Look for excluded values like we've been doing, and then classify those like we've been doing. Then you're going to be able to find the horizontal asymptote, vertical asymptote, and the hole using a little bit of the terminology we've already done in previous lessons. And intercepts is just like we did in Algebra 1. If you want the vertical intercept, you set x equal to 0. If you want the horizontal intercept, you set the output or y equal to 0. And then once you've got your 5 pieces, graph it to give you a rough sketch of what it looks like.